under root 1 minus x to the power 2n plus under root 1 minus y to the power 2n, and that is equal to a to the power n within the bracket x to the power n minus y to the power n. Then prove that dy dx equal to under root 1 minus y to the power 2n over under root 1 minus x to the power 2n into x to the power n minus 1 over y to the power n minus 1. Okay, this is question. Now starts the solution. Okay, let x to the power n is equal to sine theta and y to the power n equal to sine alpha. Okay, therefore from the question, this is under root 1 minus x to the power n. This is here sine theta, so this is here sine square theta plus under root 1 minus, this is here y to the power n, so this is here sine alpha, so this is here 1 minus sine square alpha. Okay, and this is equal to a to the power n within the bracket sine theta minus sine alpha. Okay, sorry, implies that this is cos alpha plus this is cos theta equal to a to the power n within the bracket sine theta minus sine alpha. Okay, apply the cos c plus cos d and sin c minus sin d, and that is 2 times of cos of this is alpha plus theta over 2 into cos within the bracket this is theta minus alpha over 2. Okay, and that is equal to 2 into a to the power n into cos of within the bracket that is theta plus alpha over 2 into sine bracket theta minus alpha over 2 bracket close. Okay, from the two side the 2 and cos of theta plus alpha are cancelled out, this and this, and also 2 and 2, these two factors are cancelled out from this equality. Okay, this is implies that, and this is we have left here only cos within the bracket, and this is theta minus alpha over 2 bracket close equal to a to the power n into this only has sine within the bracket that is theta minus alpha over 2 bracket close, implies that cot in the bracket theta minus alpha over 2, and that is equal to a to the power n, implies that theta minus alpha over 2, and that is equal to COT cot inverse a to the power n into that is equal to theta minus alpha, and this is equal to 2 times of COT cot inverse a to the power n, implies that alpha, that is sine inverse x to the power n minus sine inverse sine inverse y to the power no y to the power n, and this is equal to 2 into cot inverse a to the power n. Okay, now differentiate both sides with respect to x. Then the derivative of sine inverse x, that is 1 over root over 1 minus x to the power n whole square, that is x to the power 2n into ddx of x to the power n, okay, minus same derivative of y to the power n sine inverse, this is 1 over under root 1 minus y to the power n whole square, that is 2n, and derivative of with respect to x ddx of y to the power n, okay, and this is equal to, on the right hand side is constant, so derivative of right hand side is 0, so implies that, and this is actual result is n times of x to the power n minus 1, so see derivative of x to the power n into x to the power n minus 1 over under root 1 minus x to the power 2n, okay, and this is equal to 1 over no derivative of y to the power n, that is n times of y to the power n minus 1 into that is dy dx, and over under root 1 minus y to the power this is 2n, okay, so implies that now we want to find the dy by dx, so this is dy and this is dx, and equal to, from this then we first find this is under root of 1 minus y to the power 2n and 1 minus x to the power 2n into n times of that, and on the both side the n factor are cancelled, this is an n factor, okay, n this n are cancelled out, so we have left the other formation, this is x to the power n minus 1 and divided by y to the power n minus 1, okay, this is the answer, okay. See, this is our question. First we let x to the power n equal to sin theta, y to the power n equal to sin alpha, put this equation, okay, then you got the equation is this with related to theta and alpha, then apply the cos c plus cos d and sin c minus sin d, and on the both side the cos of theta plus alpha by 2 and the cos of theta plus alpha by 2 are cancelled, and also the factor 2 and 2 are cancelled out, then we got this, therefore divided by sine of this is theta minus alpha by 2 on the both side, then we got a cot of this, and this is a to the power in here, and transfer to the right hand side, that is written as cot inverse, and here is by 2, so multiply by 2, then we got this equation, and now from this we substitute the theta means here sin inverse x, and alpha means here sin inverse y, theta means here sin inverse x, alpha means here sin inverse y, okay, and differentiate both with respect to x, and then this is the equation, and if you differentiate sin inverse x to the power n, this is 1 by root over 1 minus x to the power 2n, and this is here actually into again dx of x to the power n, same as and derivative of sin inverse y to the power n, this is 1 over root over 1 minus y to the power 2n, and derivative of y to the power n, okay, and on the right hand side here is a constant, so derivative of this is 0, So now got this. Okay, so you find the answer. Okay, thank you for watching.